The topic of Lesson 1 is the addition and subtraction of fractions. To add fractions that have the same denominators, we're just going to add or subtract their numerators. Okay, so if we have 2/3, oops, my pen is going off, and I don't know why. 2/3 plus 5/3, we would have a sum of 2 plus 5, and we just re-record that denominator. They have the same denominator, and we would have 7/3 as our answer. We could leave it like this, or we could change it to a mixed number by dividing 3 into 7. 3 goes into 7 twice. With the remainder of 1, the 1 goes over the denominator. So either of these answers would be fine. This one is called an improper fraction because the numerator is bigger than the denominator. And this is called a mixed number because it has a whole number part and a fractional part. When the denominators are not the same, it's necessary to find a least common denominator and rewrite the fractions over that same denominator. So if we had, for instance, 11 over 6 minus 2 over 3, we would have to get a common denominator. The common denominator would be 6. Both 6 and 3 go into 6 evenly. This has that denominator. We just rewrite the 11. This did not have that denominator. We multiplied 3 by 2 in order to get the 6. Therefore, we have to multiply the 2 by 2 as well. And 11 minus 4 would give us a result of 7. And now we can just bring that denominator down. And again, this is an improper fraction because the numerator is larger than the denominator. We can change it by dividing 6 into 7. It would go once, and there would be a remainder of 1. Either one of these answers is fine. Actually, the answer that is the improper fraction is usually more useful in algebra. Okay, a mixed number is the sum of a whole number and a fraction. When we add or subtract mixed numbers, we handle the fractions and the whole numbers separately. So let's say we want to add, I need my pen back. We want to add 5 and 2/3 to 6 and 7/8. Okay. 3 is prime. The common denominator is 24. Has no common factors with 8. So in order to get 24, we would have had to have multiplied the denominator by 8. That means we have to multiply the numerator by 8 as well. So we have 16 over 8. And here we would have multiplied by 3 to get 24. We multiply the numerator by 3 as well. And we have 21 over 24. We want to add these two. We get 37 over 24. 16 plus 21 is 37. We divide. This is an improper fraction. When we have mixed numbers, we actually have to change this. So 24 would go into 37 once. There would be a remainder of, I'm running out of space here, there would be a remainder of 13. After we subtract 24, there would be a remainder of 13. And we put that 13 over the 24, our denominator. We now cross that out and we add that 1 over here with the whole numbers. 1 plus 5 is 6. 6 plus 6 is 12. 12 and 13 24ths is our best answer. Okay, we need to get another page up now. This is the definition of a mathematical line. A mathematical line is a straight line that has no width and no depth. It's called a primitive term. Point is also a primitive term. A point has no length and no depth. These terms can only be imagined in our minds. They don't exist in reality. A part of the line is called a line segment. So when we have a line, we put, I need my pen back again, we put these two arrows at either end to show that the line goes on in both directions. If it only goes in one direction and has an endpoint, it's called a ray, and a line segment has two endpoints. It stops. Okay? So a line segment contains the endpoints and all the points in between. We use, if we named this AC, this line AC, we would do it like this. We would have AC. We put the line symbol over it. It means it goes forever in two directions. We would have AC. If we put this over it, it means it's a ray that starts at point A and goes through point C and infinitely, forever, to the right. And this indicates line segment AC, a line with no arrows on it. Okay, this is a problem now that we have to do, adding fractions. We have three different fractions. We're going to subtract these two, and then that result, it's called a difference, is going to be added to the 1/3. They do not have the same common denominators, so we have to find a common denominator. And our common denominator, again, is going to be 66. 11 is a prime number. It has no common factors other than 1 with 6. So that's what we do when we have a prime number. We just multiply the two denominators together. We're going to multiply by 6, and we have 60 over 66. This we're going to multiply by 11 and 11, and we have 55 over 66. We're subtracting, so 60 minus 55 gives us 5, and it's over 66. We're going to take this result and we're going to add it to 1/3. So we have 5 over 66, and we have 1 over 3. And those two fractions now are going to be added together. 3 will go into 66. It goes in 22 times. They have a common factor. So 66 is the least common denominator. This we just rewrite. As long as the denominator is the same, we can just rewrite the numerator. And this 3 would have to have been multiplied by 22. So that means we're also going to multiply the 1 by 22. And that gives us an answer of 27 over 66. Now we're almost to the end of this problem. But 27 I know is divisible by 3, and I also know that 66 is divisible by 3. So we're going to reduce this fraction. We're going to say 3 goes into 27 9 times, and 3 goes into 66 22 times, and that's our final and best answer. Move on to another page now. And this is going to be a problem with a line segment. I'm losing my place here. There we go. Okay, so this is a line segment. We want to find how long it is from B to C. We don't have that. We know the whole segment between A and C is 10 1/4 units long. We know that part of the line, the segment from A to B, is 4 3/7 units long. The way that we're going to do this, you'll see in one moment, we're going to take the whole part, and part that's from A to B, and we're going to subtract them. Okay, we have to get common denominators. The common denominator is 28, as you can see here. And numerators then become 7. We multiply this by 7 over 7. And we multiply this by 4 over 4. So 7 over 7 will give us 7 over 28, and 4 over 4 will give us 12 over 28. We add, okay, we can't subtract, however. We can't subtract 12 from 7. We have to add that as 28 over 28 to 7 over 28. The shortcut method for doing that is to cross out the 7, add the 28 and the 7, and make it a 35. And that's going to give us our answer, which is going to be shown on the next page. And that's going to be, now, I think I can make this come down, 9 and 35 over 28, just like we said. And this is going to be 4 minus 4 and 12 over 28. And the final answer should be 5 and 23 over 28. And there it is. That's the end of lesson 1 and the examples.